Hello guys and welcome to my channel Learn at the Rate 10. Today we are going to learn to solve linear equations in two variables using the determinants method, also known as Cramer's rule. Let's take a textbook example. X plus 2y is equal to minus 1 is my equation number 1 and 2x minus 3y is equal to 12 is my equation 2. Now I have to write the coefficients of these equations along with their signs in determinant form. To do so, I will take d is equal to, in determinants bracket, coefficient of my first equation in line 1 and coefficient of my second equation along with their signs in line 2. Now I have to take cross multiplied product of my first cross multiplication and subtract the product of my second cross multiplication. This gives me minus 3 minus 4, which gives me the value of d is equal to minus 7. Let's now substitute the value of x coefficient with my constant in dx form. Therefore, dx is equal to, in place of coefficients of x, I will write the constants of the same equation. Therefore, in place of 1, I will write minus 1. In place of 2, I will write 12. The coefficients of y variable remain same. Now I will take the product of the first cross multiplication and subtract the product of second cross multiplication, similarly as shown above. This gives me 3 minus 24, which gives me the value of dx is equal to minus 21. Now I will substitute the value of y in my determinants with constants. Therefore, dy is equal to 1 and 2 remain same because they are the coefficients of x, whereas 2 becomes minus 1 and minus 3 becomes 12. Again, I will be taking products of first cross multiplication and subtracting the products of second cross multiplication, which gives me 12 minus minus 2. Opening the brackets causes minus sign to change into plus, which gives me 12 plus 2 is equal to 14. Therefore, value of dy is equal to 14. Now, I have to apply Cramer's rule. In this rule, I will take the value of dx and divide it by the d to get the value of x, which is minus 21 upon minus 7. This gives me the value of x is equal to 3. Now for value of y, we will write y is equal to dy upon d, which is 14 upon minus 7. Therefore, y is equal to minus 2. Therefore, x comma y is equal to 3 comma minus 2 is the solution of the given equation. Now let's learn to solve a different type of equation. Now this is not a different method, rather the same substitution method employed twice. Therefore, I call these kind of sums to be solved as double substitution sums. Now let's look at some example from the textbook. Here, 2 upon x minus 3 upon y is equal to 15 is my equation number 1, and 8x plus 5 upon y is equal to 77 is my equation 2. Now as you can see, these two equations are not in the general form of ax plus by is equal to c. Therefore, we have to first convert them into this general form. To do so, I will be replacing the 1 upon x and 1 upon y. Therefore, replacing 1 upon x as a and 1 upon y as b, we get 2a minus 3b is equal to 15. This is my equation number 3. And 8a plus 5b is equal to 77. This is my equation number 4. Now we have to solve our sum using these two equations specifically. Now, using the same method as we solved in elimination by substitution or elimination by equating the coefficients, we can solve these two equations. Here I am using elimination by equating the coefficients as my method. Therefore, multiplying equation 3 by 4, we get 4 into 2a minus 4 into 3b is equal to 4 into 15, which gives me 8a minus 12b is equal to 60. This becomes my equation 5. Now I will be solving simultaneously equation 4 and equation 5. As you can see, the coefficient of a, which is 8, is equated in these two equations. Now we will be subtracting equation 5 from equation 4. Therefore 8a plus 5b is equal to 77. This is my equation 4. 8a minus 12b is equal to 60. This is my equation 5. Subtracting causes change in sign of 8, which becomes minus, 12 which becomes plus, and 60 which becomes minus. This gives me 17b is equal to 17. Therefore b is equal to 17 divided by 17 is equal to 1. Therefore we get b is equal to 1. Now we have to substitute this value of b in any of the above equation except the first two. I take substituting b is equal to 1 in equation 3 for ease. 2a minus 3b is equal to 15. This is my equation 3. Therefore 2a minus 3 into 1 is equal to 15, which gives me 2a minus 3 is equal to 15. Sending minus 3 on the other side, I get 2a is equal to 18, and therefore a is equal to 9. Now I have acquired the values of a and b. However, my question asks me to derive the value of x and y. Therefore, I will be resubstituting these values as I replaced the x and y. Therefore, 9 is equal to 1 upon x and 1 is equal to 1 upon y, which gives me x is equal to 1 upon 9 and y is equal to 1. Now this is the solution of my equation. X comma y is equal to 1 upon 9 comma 1 is the solution. Now let's try and solve another equation as shown here in the picture. As you might have noticed that this equation is quite special because we have two variables in the denominator. The common part of these denominators is 3x plus y and 3x minus y. The 2 in equation 2 is not common throughout. However, we will not worry about it right now. Let's first try and make this equations in ax plus by is equal to c form. Therefore, replacing 1 upon 3x plus y as m and 1 upon 3x minus y as n, we get 1m plus 1n is equal to 3 upon 4. This is our equation 3. And we get half m minus half n is equal to minus 1 upon 8. This is my equation 4. As you might have noticed, the half in the coefficients is not something which I like. So we will multiply this equation 4 by 2. If the denominators of these coefficients were different, I would have taken common multiple and would have multiplied the equation by that. Therefore, multiplying equation 4 by 2, we get 1m minus n is equal to minus 1 upon 4. Now I will be taking equation 3 and equation 5 for further calculations. Since the coefficient of n is equal but in opposite sign, I will be adding equation 3 and 4. 1m plus 1n is equal to 3 by 4 and 1m minus 1n is equal to minus 1 upon 4. The n gets cancelled and we get 2m is equal to, I will be solving this fraction side by side. 3 upon 4 plus minus 1 upon 4. While opening the bracket, the minus comes out and we get 3 upon 4 minus 1 upon 4, which gives me 3 minus 1 upon 4, since the denominator is common, which gives me 2 upon 4. I will write this 2 upon 4 in the answer. Since 2 upon 4 can further be reduced, I will be reducing it to 1 upon 2. Therefore, m is equal to 1 upon 4. The 2 goes down to the denominator and gets multiplied. Now substituting this value of m is equal to 1 upon 4 in any of the equations containing m and n. For ease, I have taken equation number 3. M plus n is equal to 3 by 4, which gives me 1 upon 4 plus n is equal to 3 by 4. Solving the equation, I get n is equal to 2 by 4. And further reducing this equation, I get n is equal to 1 by 2. Now you might have noticed that we got values of our two variables, but these are not the original variables. Therefore, I will be resubstituting their values in the equation as I replace them, which gives me 1 upon 3x plus y is equal to 1 upon 4, and 1 upon 3x minus y is equal to 1 upon 2. These were my original equations. Let's take a reciprocal of these equations. Therefore, this gives me 3x plus y is equal to 4. X minus y is equal to 2, and these two are my new equations. Now I will be solving these two equations just as I solved all the other equations. Since the coefficient of variable x and y is same, I'm adding equation 6 and equation 7 because the coefficient of y has different sign. This gives me 6x is equal to 6. Further solving, I get x is equal to 1. Now, I only have to consider these two equations as I received them after solving my first two variables. And I got the value of x is equal to 1. Now I will substitute this value of x is equal to 1 in equation 6 or either equation 7. Here I have solved it by substituting in equation number 6. We get 3x plus y is equal to 4. Therefore, 3 into 1 plus y is equal to 4, which gives me y is equal to 4 minus 3 and y is equal to 1. Therefore, x comma y is equal to 1 comma 1 is the solution of the equation. Now, wasn't this an easy method? Remember to first replace the common fractions as other variables, and if there is anything left in the denominator, you can multiply the equation to remove the denominator. If there are different denominators in the same equation, then multiply the equation with their common multiple. You can practice solving other problems from the textbook mentioned in the video description. If you have any questions or suggestions, please write to me in the comments below.
The textbook questions which can be solved with this method are in the description below. Thank you for watching this video. Please like this video and help me in making videos better with your suggestions. Subscribe to my channel and share my videos with your friends. Bye.